He's been involved in the waterworks industry since 1991. During that time, he worked with many notable companies such as Robar Industries, as well as others in the underground water and wastewater markets in Canada. In Canada, in capacities ranging from inside sales to general manager. Currently, Dave is with Water Supply West Corp, where he is a company's sales director. Utilities Supply Corp works with companies to serve the underground utility markets. These markets include public works, consulting engineers, and contractors. Welcome, Dave. We look forward to your presentation.
Thank you so much. I appreciate that. So yes, my name is Dave Brewer. I am with a company called, otherwise referred to as UAC West. We're based out of Langley. And today I am presenting to you how to maintain critical water services without disrupting your customer, as little as possible, for the EOCP virtual conference. This is probably a familiar sight for everybody on the presentation right now. We've had a catastrophic failure of a water main for whatever reason. If you attended my air release valve presentation earlier today, you'd probably know what are the reasons why this might be happening. But nevertheless, we have customers who's going to be incredibly inconvenienced by this. By this time, utilities are racing to the site to hopefully be able to isolate this failure. And the news cameras are probably right behind them too. So anyways, not a fun situation for a utility, but yet a situation that happens on a too often basis. So we get to the site. The first thing we're going to have to do is we're going to have to expose the damaged pipe. What do we got? What are we getting into? We're going to assess the damaged pipe, hopefully, without an isolation immediately, and make a determination as to what needs to be done to fix the water main, or it could be a sanitary force main as well, as shown in this picture. And then typical repairs, we're going to isolate the pipe, which means we have to shut off the water or sanitary force main to this particular location. And we remove that damaged section of pipe and we tie into it with a flexible coupling of some sort or fitting. And that gets us back up on our feet again so that it's ready to go. If it's a sanitary force main, chances are you've probably got a number of pumper trucks on call right now at all the different manholes collecting at the wet well so that you can actually work on the sanitary force main. And then the end result is that we've got it all buttoned up. Everybody's happy with the job they've done. We've got, in this particular instance, you can see the large hole that's been excavated. The biggest part of this is time, but we're up and running again. And in this particular instance, that probably wasn't an issue. That wasn't going to be too critical to isolate the repair, and so they're able to accommodate it. Some of the other challenges facing a utility for this type of repair is access to the damaged pipe. As with the previous slide, you can't always, the previous slide actually is very interesting. There was no road to this repair. We had to build a road to get access to that site. But one of the challenges you might have is traffic diversion. Traffic diversion in a planned repair is not a fun thing to do. In an emergency situation, it's even less fun. Are you on a major arterial route? Is this something that can be easily accommodated? What type of terrain is involved? So unfortunately or fortunately, I've been involved in a number of emergency repairs where it's been less than favorable terrain. And so, can the trench be safely supported for entry? Can we isolate the operator from danger by properly getting the cage in place there so they can enter the hole? In this particular case, on this job right here, which I'll cover later on in the presentation, this one was exceptionally challenging. This is 35 feet from the top of the trench to the pipe. And the problem is the soils are incredibly saturated with water, which means they kept slouching into the hole. So we started off with a certain degree of slope and ended up with a very slight angle on the slope. So a large excavation is the only way it could be done to get access to the pipe. It took 3 days to get the soil stabilized in this particular project in Saskatoon. So these are challenges for the utility. These are amongst the many considerations the utility must consider when preparing for the unpredictable, which is what utilities do every day. They have a best guess of what's going to happen, but you don't know. Added up, they cost money, but moreover, They cost the utility valuable time when considering their customers may not have water. And that's where we're going to largely concentrate on today, is your major transmission mains or water mains that you just cannot lose. This is extra critical when that customer might be a hospital, now more than ever, right? Nobody wants to lose a hospital, especially with the current climate we find ourselves in these days. The potential is that this the loss of this main could affect a large segment of the population. And I can tell you right now, I know of 2 regions for sure that I'm dealing with that have no plan B should they lose the transmission. And that means a large segment of the population would have little to no water in a very short period of time. And of course, if your utility has a major industry, there's probably going to be certain commitments by that utility to make sure that industry has water. So all of these are areas where you're going to have to make sure as a utility, your responsibility is to maintain water service, if in any way possible. In instances involving diameters up to 350 millimeter, a typical repair would see the use of a repair clamp to quickly seal the leaking pipe and have it repaired as quickly as possible. Fairly straightforward, done every day throughout Canada. I've been involved in repairs of that size, and these things, I can remember in my early years, we had a consultant come in and tell our business that the repair clamps had reached their pinnacle and were on the downside of the curve. This was back in the late 1980s. By 2015, we had reached record sales for repair clamps. So they're used every day, and it's for these diameters, they're perfectly suitable to get you up and running on your feet again. With these instances, a repair clamp might be ideal as they are well suited for these diameters. The clamp's ability to form a required amount of compression on the gasket is very high. All you're doing is you're taking a piece of stainless steel and collapsing it around the pipe and compressing a waffle gasket pattern. That entire circumference of the pipe in that area where the repair clamp is we're collapsing a gasket. So in the smaller diameters, our area is small, the area relative to the ability of the lug to form compression is still close enough that that's not an issue. When we get to a repair 400 millimeters and up, the amount of gasket surface the repair clamp has to compress in order to seal the leak increases significantly. So we can see in this particular instance, which I'll come back to later, we've tried one repair clamp, didn't work. Grab another one, didn't work. And it's not because the installers didn't know what they're doing. They made the best decision with the information they had with them before the time. The challenge is that you've gone from, let's say in that particular previous slide, we've gone from 150 millimeter diameter main. You've now gone up to 600, 750, 900 millimeter. The size of our area for the gasket to be compressed evenly has grown exponentially, and we're still tightening from distant lug bars. And we're asking those lug bars to evenly compress that entire gasket surface area against what may possibly be less than perfect pipe. May not be round, may have holes, may have imperfections. At best, it's a 50-50. So as said, compound this with operating pressures above 100 psi and a pipe surface less than smooth, and the sealability of the clamp is less than certain. In my experience in these years, repair clamps, once you get above 400 millimeter, are at best 50-50. You really have to have an operator that has been around the block and knows exactly what witchcraft you need to do to make them work. And if you look at most manufacturers when they are dealing with their repair clamps, as they grow in diameter, their ability to support operating pressure diminishes. They don't want to get caught, so they say, hey, listen, it all depends on the condition of your pipe. So repair clamps have their place. On the larger diameters, it's at best a crapshoot. So fortunately, there are repair products now available that allow for the utility to permanently repair the affected pipe without the typical cut and replace. And that means a split coupling. So what we're going to be covering today is all derived from taking a basic bolted coupling. This technology from Dresser back in the early 1900s is still the same technology, except we've evolved it to basically have it modular. So we cut it in half, and we're able to assemble it around an existing pipe without isolating or removing a section of pipe. We can do the same thing with a split coupling with flanged outlets. So in this particular case, you might have something you want to do live, and you want to reroute the water away from the operators during the repair. so you can fit it with outlets. And a bell pack insulation coupling. Actually, as we speak, I've been involved in 2 projects in Alberta that are hopefully at their completion by the end of the day today, where the encapsulation vessel has been used. And essentially what you're doing is you have something on the pipe. It could be a bell spigot, could be a repair clamp, could be a coupling, could be a valve. We're going to go around it. So we leave it in place and we clamp onto the pipe and we leave it as it is. So that's an encapsulation coupling. So those are the 3 alternatives we're going to be talking about today. Available to utilities is a coupling that can be installed without either pipe being moved to install. So we're not isolating, cutting, moving a section out. Everything stays as is. This is accomplished by splitting the coupling into 2 halves to become a split coupling. These are extremely beneficial for replacing failed joints such as the bell spigot joints, coupling joints, repair clamps, what have you. So how does this work? What is this voodoo? So what you have with a split coupling is we've cut it in half. What you see highlighted here is we have actually an O-ring that seals where we've made the cut. And this O-ring is going to mate with the coupling gasket. So we have to trim the gasket on the O-ring, and it sits inside a recessed machined area on that lug bar that is then going to mate, and I'm sorry, it sits inside this recessed lug bar right here, and then it mates up with a coupling gasket that is split. So you can see an interesting feature. When you look at a coupling, we think of a solid gasket. This is a gasket that's been cut on a bias. What that means is that we are assuming that we have no ability to put an autogenous gasket in there, and that it, as a cylindrical object, we're going to have it cut and then wrap it around and put into place. And what that means is that, and we use a bias cut, because when we put this back into the coupling cavity and put it under compression, it forms as one gasket once again. Our company was asked to provide a solution for emergency 42-inch steel water main failure in the Okanagan. The steel water main had coupled joints. It was at one of these joints that the line had failed. The utility had asked if we could do a permanent repair that would allow the utility to leave the existing pipes in place and use a repair clamp style of repair. Again, I'm going to emphasize here permanent, just from my own personal experience and manufacturers I've been involved with. When we use a repair clamp, that is not a vessel that I would deem as permanent, as a permanent structure, because it certainly doesn't have the ability to provide the support to the pipe that it might need at the particular location it's being used. And over the life, maybe the pipe will deteriorate further. It offers no structural support. It stops the leak at that given time. With that being said, I know a number of utilities throughout Canada that have mains that may have been old cast at one point and have now turned to stainless steel because they have so many repair clamps on them. But I would not ever consider the repair clamp a permanent solution. The idea would be to go in there and either cut in a new spool piece or what have you. We recommended our split coupling for the repair. The fitting was air shipped in 4 days to our facility in Langley and shipped to the same day to the Okanagan. And here's the following photos from the repair. So what you can't see is on to, I guess, to the right of the photo is a big hill. It was a sloping hill. So, and there was some abutments on the other side that made it very difficult to do a larger excavation if they were going to do a cut and replace. So they wanted as small of an excavation hole as they could possibly get. And so this is what they had after we had sent them shop drawings for approval for the type of repair we recommended. So in this particular case, the coupling required rolled shoulders for the coupling. And the shoulders had corroded and corroded the pipe, and it failed. Now, these 2 rings on the inside, just between the gasket and the screwdriver, they're no longer useful. They don't serve any purpose, so they would need to be removed. Of course, if we remove that, and remember, this is a 42-inch pipe, we're going to have a large pipe gap there now. So if there was any thought of a repair clamp being used, it's out the window now. Because a repair clamp could not be used in this type of instance. It requires something to push its gasket against, and there's nothing there. So in this particular instance, you can't use a repair clamp. This gap would make a repair clamp virtually impossible to use, let alone the diameter and the required compression on the gasket. So they've done the field prep. That gap was probably about 8 inches. So this is where our coupling, the split coupling really comes in handy. What we can do is parts of the split coupling are lowered into place for assembly. It's modular. So we are using a repair clamp style, which means it can be wrapped around the existing pipe, but you get the robustness of a fabricated steel fitting that is meant to last the life of the pipe. So even should that pipe want to shift now because it's severed there for whatever reason, we are inside a bolted coupling, which means a bolted coupling is meant to isolate each pipe end from one another, and essentially each pipe end floats. If they want to deflect, they can accommodate deflection. So the coupling is assembled around pipe. Here we see the gasket being put into place. This is the bias cut gasket. They're actually stringing it around, putting it into place, tucking it into the coupling cavity. The followers, which compress that gasket, are put into place. Split coupling was ideal as it allowed the utility to assemble the coupling around the pipe without having to displace either side of the pipe. So again, a narrow excavation, they're able to do a very quick repair. It took more time to dewater this line than it did to get the coupling on place and assemble it. Once all the parts are in place, aside from some gasket interface, and remember we have to mate that coupling gasket to the O-ring, assembly is like that of a standard coupling. You're just simply doing something that many utilities have done thousands of times. The assembly time of the coupling for the utility was just under 2 hours. And this was their first time doing it. I was really impressed with the quality of work that they've done. So just a summary on this repair. The biggest challenge for this repair was properly shoring and dewatering of the line. They just didn't have enough isolating valves. And so when you have a 42-inch line, you have a long distance of dewatering. It takes a long time. Once prepared, the actual installation was done in less than 2 hours. And the 42-inch steel main was pressurized and tested by 9 p.m. of that night of the installation. No further leaks are found. Since this particular utility has more of these type of joints in their system, actually, I'm going to back up a little bit. I'm going to say, I was actually shopping at Home Depot for our new bathroom we were going to do, and I got the call, and they said, we have a big problem. Anyways, by the time I got the call and got home, we had a drawing done the next day, and so there's a bit of work that's required ahead of time to get what we need you. We just don't make the fitting right away. Anyways, long story short, we had the fitting out to them in just over 3 days. And in that particular instance, we got lucky. We can't always guarantee that we're going to be able to deliver that quickly, depending on where other utilities are in their emergency breaks. But the utility at that last line, utility has since placed an additional unit on order for their emergency preparedness. I'm going to hammer that home. If you know your mains and you know ones you don't want to lose are going to be a pain, I cannot emphasize enough, get prepared for them. Not having to go through all that rigmarole is going to save you a lifetime of headaches. So another repair we're going to talk about now is a split coupling with a flanged outlet for live repair. So this one, we couldn't isolate. And so the city of Saskatoon had a 42-inch steel main come underneath the Saskatchewan River. This main was put in the 1950s. The main developed a leak just after the 45-degree bend to come up the bank. The hole in the pipe was approximately 2 inches. There were a number of challenges facing the utility facing this repair. The main could not be isolated. The first obvious thing, well, we'll just weld it. It's steel pipes done every day. Well, they could not isolate the main enough for the weld to be done. If they did, they would be affecting a large segment of the population of Saskatoon. This is not an option for the city. The depth of the bury was close to 35 feet, so the soil stability. So we've got a question here. Can or is a lubricant, sorry, we have a question here. Can or is a lubricant for the O-ring required? Yes, in the installation of a split coupling, we do recommend lubrication be put onto the O-ring at the time of installation. This is a good question. The depth of the repair was close to 35 feet, so soil stability and shoring was a big part of the challenge. The repair would have to be done live if at all possible. We came up with a solution with their engineers of recommending a split coupling with flanged outlets. With a shop drawing supplied to the utility engineers, it was approved and decided that the live repair would be performed. The solution would need to be safely done for all involved and be done right the first time. The clock's ticking. The clock's ticking. And on top of that, the chlorinated water was flowing into a fish-bearing stream. From what I understand, this is not looked upon very favorably. Luckily in this case, this particular instance, the contractor performing the repair had previously worked with this type of product with proper training for such a fitting. So I had worked with them previously. They were well versed with this type of fitting. So I had all the confidence in the world in them. And this is you've seen these pictures already. Initially, they're exposing the job site, and because of the soils, they had heavy rains that day, so they had a lot of cards stacked against them. The amount of slope that they had to have on that excavation was huge. There was a lot of fuss about removing some of the trees local relative to the repair, but you had to be done. With the live repair, the flow continued from the hole of the pipe. So remember, this thing's flowing the entire time out of that 2-inch hole. The split coupling was then positioned over the repair to allow the water to be redirected through a flange on the bottom of the pipe. So we're redirecting that. Now there's a flange, you'll see there's a flange and a gate valve on top. They asked, the utility asked for that. I don't see the purpose of it. I think they would have been suffice with that. They could have had a little port on top of the ball valve if they wanted to bleed off air. But they wanted the flange, so we put it on there. But all the water was being rerouted at the bottom of the pipe. And then what you'll see is there's 2 hoses coming up, and we have 2 thrash pumps going. And what they did is they dumped a bunch of crushed rock, and you can see to the bottom of your left, there's a pump there, and there's another pump on the other side where they were pumping out the water. And the trench was actually reasonably dry for these guys during this repair. The split coupling was assembled on the pipe in less than 2 hours, so very similar to the last repair. No isolation of the 42-inch main was required. No disruption of service to the customer at the end of the day. So we're talking, this is a major win for this utility. They're not on the 6 o'clock news. Nobody knows on the other side of the river that there was any issue with the water supply. And they're able to do it safely for all of those involved. This would be a certainty. With more traditional methods such as welding or cutting out with 2 couplings. The biggest challenge there is how do you dewater that? How long does it take to dewater something like that? So they really didn't want to dewater it if at all possible. So this was a big win for us and the utility as well. So the summary, the delivery time for the split coupling was 2 days after approval of the submitted drawing. There was an overtime charge to accommodate this delivery. The biggest challenge I would say this was around June, so we're at the peak of our construction season for our company. The biggest challenge for the contractor was addressing the poor soil conditions around the repair, as the shoring of the site took close to 3 days. The fitting was flown into Calgary Airport, as Saskatoon's airport would not receive an air cargo shipment of this size, so they had to run a truck out to Calgary to get it. The fitting was on site the 3rd day after the order. Installation happened shortly afterward. So that's a standard splits coupling. That's where we don't have anything to worry about as far as having to go over. Fairly straightforward. Now we're going to talk about a bell pack encapsulating coupling. More involved. I haven't actually had one of these in BC installed yet. I've just finished doing 2 of them in Alberta right now. So sometimes a failure can happen on a bell spigot joint or coupling or repair column. And here you can see this is somewhere in Florida, some lagoon. That's actually a wastewater line, and it is dripping sewage into the lagoon. And there's some pretty expensive boats there, so I'm going to assume that that's not looked on too favorably. I'll also have to assume that they couldn't isolate this for repair, so they could take that off and replace it. So what we ended up doing in this particular instance is just encapsulating the entire fitting and sealing it off so it wouldn't affect or leak anymore. And again, no service disruption or anything of that like. In these instances, a bell pack encapsulation fitting can be used to go over the leaking fitting to seal it off without having to isolate and cut into the line for removal of the fitting in question. In this case, the same type of sealing parameters are in place. So we're using the same O-ring on the lug bar section. We're using the same type of coupling gasket. The only thing that might change is we might change from a traditional C219 coupling seal to a C111 mechanical joint seal, depending on the requirements of the fitting. In this case, the same type of sealing parameters are in place, except for fabricating of the fitting takes the repair scenario into account to make sure that the encapsulating fitting can properly be cleared. A very useful fitting for those water mains that cannot be isolated for repair. So I have some real interesting scenarios here to show you. So this one here, if your volume's up with whatever you're listening to, you might want to turn it down a bit. But this is in the Carolinas where they've got a bell spigot on a line that can't be isolated. And it's live, and it's leaking like that. And so we've got we've already got, if you can see in the bottom, we've got the bottom piece in place. So what's going to happen next is, and that the gentleman with the yellow hat on is George Gaber, and he's not with us any longer, but he was just a fantastic wealth of information. And he's on site helping this thing be put together. And what you can see is they've actually got a flange diverting the water. This is a warm climate, so clearly they're not worried about being wet. But you can see the assembly of the fitting. It's going up and over that failed bell spigot joint. It's fairly straightforward. We're basically got the same center lines on either side of the joint. So essentially, we've gone up and over the fitting, and this is a similar fitting that we just did in Alberta as well. And that's what we end up with at the end of the day. So it's anticlimactic, but at the end of the day, we haven't shut down the water service for anybody. We've had, and this looks like a pretty involved excavation. The installation, I'm not aware how long that took, but no isolation of the main was required. Everything was kept live. So that's one example of a failed bell spigot joint with encapsulation coupling. This one's kind of funny. Again, this is down, I think this is in Georgia. But I call this repairing the repair clamp. So this is the earlier slides. We're talking about repair clamps that just don't work. Like I said, I'm not saying not every time, because sometimes large diameters will work, but in some instances they don't. Now what have you done? You've lost time. You've lost time. So in this particular instance, what we're going to see is an encapsulation vessel used to go up and around the repair clamp. So this has got a pretty good flow to it, and you're getting wet. So in this particular case, we have to assume this is a critical main that cannot be shut down again, or it can't be isolated, and it must be kept going, and they have to do it live. So you're going to see here is an interest. They got the port at the 12 o'clock position. I would not recommend this be done at the 12 o'clock position. I would put it at the 4 or 6 o'clock position, and you're going to see why. You're definitely having a shower that day to put this fitting together. You're going to see they have a gate valve at the top of that thing. They probably look like they're getting ready to button it up to shut off the gate valve. But anyway, they do have a pump down there at the bottom. You can see the hose going in there to pump out the trench, but it's doing nothing for the guys having a shower. And then at the end of the day, they were done. So again, we've gone around the repair clamp. The biggest difference between a repair clamp and the coupling as well is that you're talking about a very small cross-sectional area of gasket of which we have to form compression on to form that seal on the pipe. So we don't need to have like a 4-foot section of excellent pipe. We just need to find a good enough section for us to seal on, and we can make the seal. Now, if that pipe wants to go into shear or break, I can accommodate that within the fitting because I can articulate with my coupling gaskets. A repair clamp, in my personal experience, I've had them go on, they work okay. A year or two later, the pipe shifts. A repair clamp cannot handle any type of movement in the pipe at all. They're just not made for that, and they leak. So this is another example of a bell pack encapsulation coupling. This is on a smaller line. And what's happened here, I don't know the particulars of it, but this is I have to assume, it might be a fire line that it's not allowed to be taken off for insurance purposes. But we've got, and this would be a straightforward repair any other day of the week. Isolate, change your packing on the gate valve, put it back together, done. But they couldn't isolate it for whatever reason. We can help out. So in this particular case, we have a bell pack encapsulation coupling that would go around the in-place gate valve. And at the end of the day, it's assembly. This one is fairly straightforward. But you can see we go up and over the bonnet, and that's what you end up with at the end of the day. So customer is able to maintain, if that was a fire line, I have to assume that's what that was. And nobody's wiser for the wear, and the customer's happy. So just really quickly in review, split couplings for your emergency repairs, often more traditional methods. I would say 95% of the time, traditional methods, temporary or permanent repairs, are adequate for the utility to bring the water main back online. They have the time, they have the luxury. It's fairly straightforward. We're not talking about the straightforward repairs for these types of fittings. And here we got a repair clamp on looks like a 200 millimeter line, and the other picture is a 100 millimeter line. Those type of repairs are done multiple times every day in a utility. That's not what we're talking about. However, for those utilities with critical mains that must be kept going with little or no disruption, specifically those considered large diameter, I typically associate that 400 millimeter and above. The split coupling is well suited to provide a solution the first time when it is critical. And so in this particular instance, you got one chance to get it right. And so this is, in my experience, been the successful methods more often than not. You know, as any emergency plan, preparation is key. In the Lower Mainland, there's a couple of utilities that have taken extra precautions, seismic well, actually on the Vancouver Island as well. You know, preparing for a seismic event. The ground, in some areas that are located, I've been identified, we're going to have permanent ground shift, some plate shifting. Pipelines are going to be subjected to failure. Know those lines, know where they are. Having something like this is going to play a critical role in getting your water main up and going again. Identify your water mains or force mains that must be kept in service with little or no disruption. Are they large diameter? If it's a smaller diameter, a repair clamp will suffice. What's their age? Is there anything special about the pipe we should know? If you call me up and you say, I've got an emergency, I need you down here, I need one of those split couplings or encapsulation repairs, I'm going to ask a couple things. I'm going to ask, what's the pipe's age? When was this pipe put in? If you tell me like the 1950s or 60s, the first thing I'm going to ask, is it round? Because sometimes that pipe will take the shape of the earth that's around it if it hasn't been properly supported. More times often than not, that's not the case. So we need to know it's round. What are the expected operating and surge pressures? Those have to be taken into consideration in order to accommodate the proper construction of the vessel. Having this knowledge ahead of time and then preparing accordingly with the fittings in your inventory will allow your utility to be prepared for failures with critical water mains and go from this little geyser here to a quick shower to this. Nothing to it, right? Okay, so that's it. Thank you for your time. I'm Dave Brewer with USC West at the EOCP Virtual Conference, and I'm available for any questions you might have right now.
Thank you, Dave. That was great technology. I think you'll be getting a few calls from a few municipalities for.
They don't know they need it yet.
Exactly, but you're right about the emergency preparedness and having it in stock so it's there when you need it.
Yeah, there's a number of utilities I'm dealing with right now that are actually taking steps and actually, I mean, it's not just my fitting, other fittings, and they're actually getting budgets built specifically for these reasons, for the emergency preparedness. I have another question. James Austin, I don't know if you already mentioned that, but are both of these devices suitable?
Is Dave in the picture?
I am in the picture now. Sorry, James Austin has a question with regards to, are these devices suitable, are these type of vessels suitable for all types of water pipe, specifically larger concrete pressure pipe? Yes, James, I know you have some of that pipe out there. So the question is related to pre-stressed concrete cylinder pipe, which is otherwise referred to as concrete pressure pipe. And so the challenge with that type of pipe is that it doesn't have a uniform surface. The exterior surface of a concrete pressure pipe is with a shotcrete, which means it's basically centrifugally applied and it's not uniformly flat. And so one of the challenges, we don't have a flat surface to go against. And so in those particular instances, we actually have concrete cylinder adapters, which I also do, that we have. But in order to install those, unfortunately, James, you have to isolate your water main. You have no other choice unless you've got a real big concrete plant right next to you and you can form around it and just dump concrete all day. But no, you can't. Aside from concrete cylinder pipe, asbestos cement, old cast, ductile, PVC, steel, these are all, the only one that I just recently had a call for up in McBride in British Columbia was for a 42-inch FRP line, fiberglass, reinforced fiberglass. And we were not confident with the ability of that, and there's no slight against the pipe, I'm sure it is. We just had no testing that we could qualify our fitting would be able to form a seal and maintain a seal without collapsing that pipe. And so we just couldn't say. But all the other pipes are on the table. Unfortunately, with concrete cylinder pipe, you do have to isolate and cut in. And it's funny you say that because I'm actually going into EBCOR, who runs the utilities for a city of Edmonton, and they have just recently identified a number of areas that they have where they have 750 and 900 concrete cylinder mains. They just had them analyzed by Pure Technologies, and they're about to give up the ghost. And that would be a major catastrophic failure. That pipe doesn't just like spring a leak, it explodes. And so this comes back to that preparation. I'm heading out there later on this month to do some dry runs with them on how we're going to do the repair. And so there's only one way to repair that, James, and that's by cutting in and using the adapters, which I can help you with if you're interested. Good question, though.
Is there any more questions?
Oh, you know what? Sorry, if I could, I'm sorry, just really quickly.
Please do.
There was a gentleman from the first presentation, which was interesting this morning. The question was, I'm sorry, what was that question again? Sorry, yeah, retrofitting. So I'm sorry, for those of you who might be on this presentation that may have asked that question, retrofitting an existing air release valve chamber so that it could be maintained from ground surface. Yes, there's a number of ways that we can do that. The simple way, if it's a potable water, is that we are just going to take our vessel and then mount it directly onto the existing method that's on there. Obviously, we have to isolate, remove the old valve, assess what we have there existing, see if there's any additional support required. But it could be as simple as screwing on a 2-inch male nipple and then spinning on our self-contained set and then supporting it while we backfill it with crushed rock. That's it. It's that simple. So I haven't done that yet, but we've done it a couple times in Alberta. So sorry, I just wanted to answer that question from this morning.
Absolutely.
So, okay.
Thanks
Great.
a lot, Dave. Much
Thank you.
appreciated. And thank you, everybody.